Coming to the first problem, determine which of the following polynomials has x plus 1 a factor. The first polynomial given to us is x cube plus x square plus x plus 1, and the second polynomial is x power 4 plus x cube plus x square plus x plus 1. So in order to find the solution of this problem, we need to make use of factor theorem. So the factor theorem states that if p of x is a polynomial of degree n greater than or equal to 1 and a is any real number, then x minus a is a factor of the polynomial p of x if and only if p of a is equal to 0. So this is the factor theorem. By using this factor theorem, let us determine x plus 1 is a factor of the given polynomials or not. So the first polynomial is given as x cube plus x square plus x plus 1. So we can write it as p of x is equal to x cube plus x square plus x plus 1. And the given linear polynomial is x plus 1. So first equate the given linear polynomial x plus 1 is equal to 0. So we get x is equal to minus 1, which is a 0 of the polynomial. Now let us substitute minus 1 in the place of x. We get p of minus 1 is equal to minus 1 whole cube plus minus 1 whole square plus minus 1 plus 1. So we get minus 1 whole cube is minus 1 and minus 1 whole square is 1. This is minus 1 plus 1, which gives 0. That becomes p of minus 1 is equal to 0. By our factor theorem, we can say that x plus 1 is a factor of the polynomial x cube plus x square plus x plus 1. Now coming to the second problem, which is x power 4 plus x cube plus x square plus x plus 1. We can write it as p of x is equal to the given polynomial x power 4 plus x cube plus x square plus x plus 1. And the 0 of the polynomial, we have obtained it already by x plus 1 is equal to 0 and x is equal to minus 1. So let us substitute x is equal to minus 1. That is p of minus 1 is equal to minus 1 power 4 plus minus 1 whole cube plus minus 1 whole square plus minus 1 plus 1. This gives 1 minus 1 plus 1 minus 1 plus 1. So this gives plus 1 and minus 1 gets cancelled, minus 1 and plus 1 gets cancelled. Finally we will be getting plus 1. So p of minus 1 is equal to 1, which is not equal to 0. Therefore, by factor theorem, we can say that x plus 1 is not a factor, since p of minus 1 is not equal to 0. Coming to the second problem, use the factor theorem to determine whether g of x is a factor of p of x in each of the following cases. We have been given three polynomials. P of x is equal to 2x cube plus x square minus 2x minus 1, and g of x is equal to x plus 1. And the second polynomial is p of x is equal to x cube plus 3x square plus 3x plus 1, and g of x is equal to x plus 2. The third one is p of x is equal to x cube minus 4x square plus x plus 6, and g of x is equal to x minus 3. So let us First state what is factor theorem. So the factor theorem states that if p of x is a polynomial of degree n greater than or equal to 1 and a is any real number, then x minus a is a factor of p of x if and only if p of a is equal to 0. So let us find the 0 of the polynomials, and hence if we show p of a is equal to 0, then x minus a will be the factor of the given polynomial p of x. So the first polynomial given as p of x is equal to 2x cube plus x square minus 2x minus 1, and the other one is g of x is equal to x plus 1. So first let us find the 0 of the polynomial. It is obtained by equating g of x is equal to 0, which gives x plus 1 is equal to 0, which is x is equal to minus 1. So let us substitute minus 1 in the place of x, which gives p of minus 1 is equal to 2 times of minus 1 cube plus minus 1 square minus 2 times of minus 1 minus 1, which gives 2 times of minus 1 plus 1 plus 2 minus 1, which is equal to, this is equal to minus 2 plus 1 plus 2 minus 1. Minus 2 and plus 2 gets cancelled, 1 and minus 1 also gets cancelled, which becomes 0. Therefore, p of minus 1 is equal to 0. We can say that x plus 1 is the factor of the given polynomial p of x, which is 2x cube plus x square minus 2x minus 1. Now the second one is let us use factor theorem here also. First find the 0 of the polynomial. It is x plus 2 is equal to 0, which is x is equal to minus 2. Substituting the value of minus 2 in the given polynomial, we get p of minus 2 is equal to minus 2 whole cube plus 3 times of minus 2 whole square plus 3 times of minus 2 plus 1. Minus 2 whole cube is minus 8 plus 3 times of minus 2 whole square is 4 minus 6 plus 1. This is equal to minus 8 plus 12 minus 6 plus 1. This is equal to minus 14 plus 13, which is minus 1, which is not equal to 0. Therefore, by factor theorem, we can say that g of x, which is x plus 2, is not a factor of the given polynomial p of x. Coming to the third one, which is p of x is equal to x cube minus 4x square plus x plus 6, and g of x is equal to x minus 3. First find the 0 of the polynomial by equating g of x to 0. We get x minus 3 is equal to 0, which is x is equal to 3. On substituting x is equal to 3 in the given polynomial, we will be getting P of 3 is equal to 3 cube minus 4 times of 3 square plus 3 plus 6. 3 cube is 27 minus 4 times of 3 square is 9 plus 3 plus 6, which is equal to 27 minus 36 plus 3 plus 6, that is 36 minus 36, which is equal to 0. So we got P of 3 is equal to 0. By factor theorem, we can say that x minus 3 is a factor of the given polynomial P of x.